In 1989, a stretch of land called Susie Creek in northern Nevada was nothing but a barren gravel bar. There was no water, no willows, no green of any kind, just dry stone and dust. Nevada is the driest state in the country, getting less than 10 inches of rain a year, so a dead creek bed was not unusual. What happened next, though, was unusual. In the early 2000s, a small number of beavers moved back into that stretch of desert on their own. They started doing what beavers do, cutting sticks, packing mud, building dams across the water. Nobody expected much from this. Scientists who studied the area assumed the dams would fall apart within a season or two because deserts are simply not supposed to support that kind of animal or that kind of structure. But years later, after the region went through a 4-year drought, the worst one on record, researchers went back to check on Susie Creek. What they found did not match anything they thought they knew about desert water systems. The creek was still running. It flowed all year, even through the drought, while ranches nearby were trucking in water just to keep their cattle alive. To understand why that matters, it helps to look at what has been happening to water across the American West for the last century and a half. The region is losing water, and while the current drought is severe, the deeper problem started long before this dry spell began. Before European settlers arrived, scientists estimate that North America was home to as many as 60 million beavers, and some think the real number could have reached 400 million. These animals built dams on nearly every stream on the continent. The result was a huge connected system of ponds, wetlands, and slow-moving water that held enormous amounts of water in the landscape at all times. Then the fur trade began. Between the early 1800s and the late 1900s, hunters and trappers wiped out more than 90% of the beaver population. In many regions, they disappeared completely. Here is what that loss actually means for a place like the West. Most of the region's water starts as snow that falls in the mountains each winter. When spring comes, that snow melts and runs downhill. In a system with healthy beaver dams, this meltwater would be slowed down, spread across the land, held in ponds, and pushed down into the ground to recharge underground water supplies. Without beaver dams, none of that happens. The water rushes through in a matter of weeks, and then it is gone. Streams that should flow through the entire year are often bone dry by August. Climate change is making the problem worse. Snowpack is shrinking. Snow is melting earlier in the year, and summers are getting longer and hotter. If there is no way to store water in the landscape, then there is no water left by late summer, which is exactly when ranchers, farmers, and wildlife need it the most. For most of the last century, ranchers saw beavers as pests. Beavers flooded pastures, blocked irrigation ditches, and cut down trees that gave cattle shade. So ranchers trapped them, shot them, and sometimes used dynamite to blow up their dams. John Griggs remembers doing exactly that. In 1990, as a young cowboy on the Maggie Creek Ranch in Nevada, one of his early jobs was to destroy a beaver dam with explosives. He recalled sticks flying through the air and loud booms, though he admitted they had no real idea what they were doing, and it barely made a difference. At the time, the attitude was simple. Beavers were the enemy. That began to change when a wildlife biologist with the Bureau of Land Management, Carol Evans, suggested something the ranch had never tried. She asked what would happen if they changed the way cattle grazed near the creeks, moving the herds away from the water during the hottest months instead of letting them stay there all summer, trampling the banks and fouling the water. Griggs agreed to try it. In the first year, native grasses started coming back. In the second year, flowering plants returned. By the 8th year, something nobody had planned for happened. Beavers showed up on their own. Griggs was reluctant to let them stay, given everything he had been taught about beavers, but Evans encouraged him to give it a chance. They let the beavers remain, and the animals went to work, doing what Griggs later called phenomenal restoration on their land. 3 decades later, Griggs manages that same ranch, now spanning 200,000 acres, and serves as president of the Nevada Cattlemen's Association. He still wears a beaver felt hat, but now he speaks at conferences across the country about the benefits of beaver-driven land restoration. He has said it took a real shift in thinking because his generation grew up after the beavers were already gone, so nobody understood what had been lost. The most important part of this story is something most people never think about. A healthy creek is not just the water sitting on the surface that you can see. Underneath it is a kind of sponge, a saturated layer of ground that keeps the whole flood plain hydrated. When beavers build a dam, they slow the water down and back it up behind the structure. That backed up water does not simply sit there. It filters down into the soil, raising the water table and soaking the surrounding land. Plants grow, and their roots hold the soil in place. It works something like a battery being charged during wet periods, then slowly releasing that stored energy, in this case water, back into the stream during the dry season. A trickle that would have disappeared by midsummer instead becomes a steady year-round flow. This same process explains something scientists got wrong for decades. It was long assumed that beaver ponds would act like bathtubs, sitting still under the sun and heating up to dangerous levels for cold water fish. Research has since shown the opposite is true. The water in these ponds is constantly being refreshed by cool groundwater rising up from below. A 2017 study on Bridge Creek, a high desert stream in Oregon, found that the surface water near beaver dams could be as warm as 25 degrees Celsius, hot enough to stress trout, while the groundwater rising just below the dam was 4 to 5 degrees cooler. That small difference is often enough to decide whether fish survive the summer or not. In Washington state, researchers moved 69 beavers into headwater streams and tracked what happened downstream. On average, the water in those stretches dropped by 2.3 degrees Celsius during the hottest, driest part of summer. The beavers were not just storing water, they were cooling it. The trouble is, there are not enough beavers to fix every damaged stream in the West, and in many places the streams are too badly eroded for beavers to move in and start building on their own. The banks are too steep, the vegetation is gone, and there is nothing left for them to work with. To bridge that gap, people started building something called a Beaver Dam Analog, or BDA. It is exactly what it sounds like, a structure built by humans that mimics what a beaver would build. Workers drive wooden posts into the stream bed, weave willow branches between them, and pack the gaps with mud and plant debris. The finished structure looks like a beaver dam, a little too neat and even to be the real thing, but rough enough to function the same way. What makes this approach appealing is the cost. Traditional engineered river restoration runs anywhere from $30,000 to $50,000 per mile of stream and needs continual upkeep. A beaver dam analog costs somewhere between $1,000 and $4,000 per mile and needs almost no maintenance at all. Joe Wheaton, a geomorphologist at Utah State University who helped develop the method, has pointed out that instead of spending $1 million on a mile of stream, you might spend $10,000. In Idaho, a rancher named Jay Wild had spent years trying to bring life back to Birch Creek, a stream on his land that used to run for only a few weeks each spring before drying up completely. Nothing he tried made a lasting difference. In 2015, he partnered with Utah State University to build 19 beaver dam analogs on the creek and release 5 beavers into the area. The very next summer, Birch Creek stayed wet 2 full months longer than it ever had before. Even better, the beavers took over the human-built structures, reinforcing them with their own sticks and mud, and improving on the original design. One of the researchers involved said it was remarkable to watch, because the beavers simply did a better job than the people had. The goal behind this kind of project is straightforward. Build a starting structure, let the beavers take over, and then step back and let nature run the system. One of the most pressing reasons for this work is saving fish that are running out of places to live. The Lahontan cutthroat trout is Nevada's state fish, and it once lived throughout the Great Basin. Today it is threatened, and warming streams caused by climate change are shrinking its habitat further. Carol Evans, the same biologist who worked on Susie Creek, began her restoration efforts specifically to help bring this trout back, and her research suggests the area could fall outside the fish's survivable temperature range within a few decades. The cold, deep pools created by beaver dams, fed constantly by groundwater, may be one of the only places left where these fish can survive as everything around them warms. This pattern is not limited to Nevada. In Oregon, the Bridge Creek project used Beaver Dam Analogs to help increase local beaver populations tenfold, specifically to support endangered steelhead. In Utah, similar restoration work is helping native trout as well as the greater sage grouse, a bird that depends on the same wet meadows beavers help create. In Montana and Washington, moving beavers into degraded streams is now written into official state plans for adapting to climate change. Unlike concrete dams or mechanical cooling systems, these dams cost almost nothing to build and maintain themselves without any outside help. Today, beavers can be found along 11 miles of Susie Creek and 16 miles of the nearby Maggie Creek Basin. The gravel bar that sat lifeless in 1989 is now a wide wetland full of cattails and willows, with deep ponds holding water throughout the year. Ducks, geese, egrets and sandhill cranes now live there, along with muskrats swimming through water that used to be dry dirt. Even during the recent 4-year drought when ranchers in the surrounding area had to haul in water for their herds, Susie Creek kept its ponds full and its water flowing. None of this was built by engineers, funded through a massive infrastructure budget, or planned by any government water agency. It happened because a small number of rodents kept building with sticks and mud. This same shift is happening across Colorado, Wyoming, Utah, Nevada, Oregon, Idaho, and Washington. Federal agencies are constructing beaver dam analogs on public land. Ranchers who once saw beavers as a nuisance are inviting them back onto their property. Wildlife departments are catching beavers causing problems in urban areas and relocating them to streams that badly need their help. Carol Evans has described this moment as a kind of Beaver Enlightenment, a growing understanding of how much good these animals can do simply by being allowed to do what comes naturally to them. For a century and a half, water in the American West was managed with concrete, steel, and heavy machinery through dams, canals, pipelines, and pumps that cost billions of dollars to build. In the process, the natural systems that used to hold water on the land were drained away. Now, facing the worst drought conditions in over 1,000 years, people are relearning something that once would have seemed obvious. The most effective way to keep water on the land is to slow it down, and the most efficient workers for that job are animals that do it for free. This is not simply an appreciation for nature, it is plain economics. Relocating a beaver costs around $1,000. Once in place, it works constantly without pay, building structures that hold up on their own, improve with time, and create habitat for dozens of other species along the way. No construction crew can match that kind of return. The most important point in all of this is that the desert is not actually short on water. The water is simply in the wrong place at the wrong time, rushing through in spring and vanishing before summer even begins. Beavers solve that problem by catching the spring flood and holding onto it through the driest months. John Griggs, the same rancher who once destroyed a beaver dam with dynamite, now explains that when beavers slow water down and back it up, they recharge the underground sponge that lets the surrounding plants and grasses spread. Carol Evans puts it just as plainly, saying you cannot have healthy land without healthy water, and you cannot have one without the other. Joe Wheaton has made a similar point about the structures he helped design, saying that what matters is not how long any single human-built dam lasts, but whether it gets beavers back into the system so they can take over the work themselves. Susie Creek went from a barren gravel bar in 1989 to a thriving wetland today, and the only real difference between those two versions of the same place is a small number of animals working quietly with nothing but sticks and mud.